Well, good evening, everybody. It's just a shade before 7 p.m. Eastern time. I don't know what time it is wherever you are. That's up for you guys. That's for you guys to do the math. But
Figure it out.
welcome to another fun edition of Takeo After Dark. The little project that started as how are we going to train people during a pandemic that's turned into an international craze, I think. Rick, you agree? I mean,
Well, it's got a lot more legs than we ever thought it would get.
that's right. This has become an international sensation. And so we're really psyched to have you here. I'm John Barba from Takeo Comfort Solutions, joined by Rick Mayo, also of Takeo Comfort Solutions. So yeah, hey, there you go, Rick. That's right. That's closely spaced tees right there. Awesome. Good to have you back. You were had a little vacation thing going on, which
Yeah,
must have been nice to get on an airplane and go somewhere. How was that? That must have been weird, man.
it was. I've done it a couple times since the COVID thing, but this was okay. You just gotta wear your mask for the most part. They want you to wear your mask in between sips, if you guys get what that means. So
Yeah, okay. Well,
speaking of sips, just
there you go.
water right
Speaking
now.
of sips, just
Later.
water. Right, there you go. Later, right. We'll be doing quarantinis. Remember that was McGrath remembers that from our very first episode. We had quarantinis.
I love it.
All right. Lurking in the background, we have our partners in crime, John Messenbrink and Tim Ward. Guys, how you guys doing?
I'm doing well on this end.
Good, John. How you doing?
Doing outstanding. Psyched for another big night.
I'd pop on camera, but I haven't showered today, so I'm just gonna lay back.
Well,
here.
that doesn't come across over the internet, John.
But I gotta say, I haven't seen Rick in a while. His beard and mustache looks fabulous. Look at that.
Hey,
Any grooming hints for your fans there, Rick?
I'm going back. I'm going back for the what's my little character?
Oh yes, the Lorax.
The Lorax.
The Lorax.
There's our man, the Lorax.
Oh boy.
All righty.
Thanks for wheels for that one. So.
There you go. Hey, well, just so everybody out there knows, if you haven't been with us before, Mechanical Hub, both Tim and John with Mechanical Hub have graciously helped co-sponsor these Takeo After Darks going back, almost a year and a half now. And we do appreciate that, and we appreciate the support and partnership. And guys, just could you share what's going on Mechanical Hub this week for our audience, guys who may not be familiar with Mechanical Hub?
Well, we always try to keep contractors updated with the latest news and technology. You have a story up there on the latest regulations on ECM circulators, so that's a cool read.
Not regulations, John. Not regulations.
I'm sorry.
They're not regulations.
Guidelines. Not yet. Not yet.
Ratings.
Ratings. They are ratings. There we go.
Yeah. Yes. But yeah, so I just returned from a vacation fishing, so
good for you.
Back into the swing of things, and like you had mentioned with Rick, getting back to traveling and visiting different places and different shows. So hopefully that all goes as planned in the next few months.
Yeah, check out the new podcasts. They're fun.
Oh yeah.
Even one up there. There's even a Eric Ani and Andy Mickelson one up.
The elusive Eric Ani, as far as I know. We'll be sending a message to Mr. Ani in just a moment. So, all right, hey guys, thank you for being with us, and for all you folks out there, if you haven't checked out mechanicalhub.com, do so. It'll be well worth your while. A lot of great stuff there, and it's all designed to help us in the trades do our jobs better and more efficiently, more effectively, and more profitably. So it's a great place for you guys to go hang out.
Well, thanks, and we appreciate you doing this every week, and we appreciate the knowledge, so thank you.
Oh, you're welcome, and thank you. All righty, great. Well, let's get started to Takeo After Dark, the summer series. This is episode 3, sizing, piping, and pumping for indirects. And of course, there's our patron saint, the most interesting living American, I believe, is the one and only Bruce Campbell, the most interesting living American. This side of Dolly Parton, maybe, because she's pretty cool too. But Bruce Campbell is our spirit animal, our guiding light, the person that we look to for inspiration. So what do we expect from Takeo After Dark? Again, if this is your first shot here, I see a lot of names that are familiar, and I see several that might be your first time. So thank you for being with us, you first timers. So what are you going to expect? Well, the summer series, we're about halfway through now, 5 weeks on assorted topics. They're not really related to one another. It's just a gathering of discussions designed to fill the summer. It's and help you guys with any information you might need going into the fall heating season or anything plumbing related, which really has no season. As we said before, all of these classes are individual class registrations. You'll be notified. We toyed with the idea of one sign up for everything. It just really didn't work. The GoToWebinar setup isn't really set up, doesn't really lend to that kind of registration. Unfortunately, you can do it, but there's a lot of drawbacks to it. So we decided not to do it. Class recordings are available. Of course, you will get a follow-up email tomorrow at this time with a link to your to download your certificate of attendance, as well as a link to view the class recording. You can view it as many times as you want. There's no limit on there. And then if you go to Mechanical Hub's YouTube page or our YouTube page, you'll see just about every Takeo After Dark we've ever done going back to the last year and a half. If you've got nothing to do for like an entire long weekend, like say Labor Day weekend, you've got nothing to do but sit in front of a computer, order up a bunch of pizzas and watch them all. It'll tell you what, it'll be great. You'll enjoy it. So yeah, on both of those YouTube channels. Tonight, as always, we have rewards for participation. We've got prizes, we got giveaways, we got awesome shirts like the one I'm wearing right here, the Takeo After Dark shirt. On the back has the big logo. On the front, it's got the little logo, and on the sleeve, it's got the Takeo logo. So we'll be giving away a bunch of those, and we have a big prize for tonight. I can't remember what it is. Dave's not here, man. But
Yeah,
Dave is the keeper of the prize. He had to go do some fatherly duties tonight, but he will be back before we're all said and done. And again, as always, lots of learning, lots of laughs. So let's meet tonight's cast of characters. All right. Ferris Bueller's Day Off is our movie theme for the evening, and Dave's not here, right? So
Yep.
we go back to Cheech and Chong. Dave's not here, man. So Rick and I are taking over the con, and Rick, again, you fellas have nothing to worry about. He's a professional, right? Rick is, as I said, all three of us have talents. Rick's talent is being the smartest of the trio. All right. I mean, he's on the Takeo training tricycle. He's the big wheel, as far as I'm concerned.
Yeah.
So again, control panel stuff. Just want to make sure you guys know what's what. Audio section up there. Make sure you can hear us. I hope you can hear us. Handouts to download. Unfortunately, no handouts this time, but next time, I think next week, I believe we will have some for you. And then the question and chat section. That's the most important part. An awful lot of you folks have already chimed in.
Yep.
Could you do me a favor? Go to that question and chat section on your control panel and just say, hey, how you doing? Let us know that you can hear us. Let me know that you know how to type these questions in and everything. So Travis, great. Mark, William, excellent. Paul, terrific. This is going to be how you're going to ask questions throughout the presentation. And one of the things we don't do, we don't wait till the end. We don't tell you, hey, hold all your questions till we're done talking, because we don't want to hear from you until we're finished. Nah, that's nonsense. Ask your questions as you think of them, and we'll take a break every few slides to look over them, and we'll try our very, very best to answer everything we can. And if we don't know the answer, we'll tell you that too, because nobody knows everything, right?
That's right.
I know a few people who believe they're the guy that knows everything, but trust me, they do not know everything. So great. So that's if you are on a desktop. If you are on a device of some sort, it's going to look similar but different. So you've got your screen toggle, go back and forth between webcams and the presentation. There's your audio settings, and then that all important question mark down there in the corner. If you want to ask a question, you just click on that and you'll see it all. So excellent. Very good. Very good. Very good. And before we get started, as we are getting ready to rock, again, this is the third installment of a great new feature in Takeo After Dark. All right. It's a great new feature in Takeo After Dark, and we're going to play this feature. This is a great game, and you win a prize. It's time to play. Where's Eric? Because he ain't here. We invite him every week, don't we, guys? John, Tim?
You do, yep.
We invite Eric every week. We invite Eric every week, but he's always seems to be someplace else.
I think he'd love this segment.
He always seems to be someplace else. So tonight, where's Eric? What I want you to do, and this is for a prize, this is for a t-shirt. Once I show you the picture of where Eric is tonight, if you know where he is, all right, type it in, And for all the people that get the answer correct, we'll pick our favorite person to win the prize. And we'll be doing it at random. So you'll have till the end of the class to figure out where Eric is. But where is Eric tonight? Here's Eric. There's Eric tonight. Where is that? That's a cool
Machu
place,
Picchu.
wherever it is. It's high up in the sky. It's very high up in the sky, as you can see. Where is Eric? If you know, type it in, and by the end of the night, we'll have a prize for one of you guys that got it right. Okay. All right. Looks like a lot of people kind of got it figured out. All righty. Great. All right. So there's Eric. And let's get started. Let's get back to work. Ferris has got his vocal cords all warmed up. And let's talk about some indirects. Let's talk about some indirects. Indirect water heaters are cool, man. They act as another zone off of the boiler. I've heard people say, well, it's free hot water. Well, no, not really. It's
No.
BTUs being consumed to create hot water. So it's not really free. It's just a really efficient way to make a lot of hot water, provided you do the stuff that you're supposed to do correctly, provided you could read the sheets, read the spec sheets and understand what they're telling you, and then size things properly. All right. And another question that always comes up when we're talking about indirects, well, what if the domestic hot water load is different from the boiler load? All right, do I size the boiler for the heating load, or do I size it for the domestic hot water load? Well, yes, yes, you do, and no, you don't. You can do it either way, and we're going to show you how to do it either way, and then you can figure out what it is you're going to need for your application. So we're going to go over that as well. The reason I first developed this class had to do with a story a long time ago in a galaxy far away at a radiant floor heating manufacturer that both Rick and I, and Dave for that matter, we all worked at one point or another. But this was very early in its tenure, 1995, at Worsbo Company. And we had a purchasing agent. Back then, there was one guy who did all the purchasing. That's how small the company was back then. And he was building a house, and this guy Rick would not Rick Mayo, not Rick Mayo. This was the other guy's name was Rick. During the construction process, Rick would bother anyone with ears who had any kind of technical knowledge whatsoever to kind of help him out to figure out what he wanted to do. And we had an early warning system at the company, where Rick was always, the first guy. When Rick would get in a little bit after everybody else. So the guy whose office faced the parking lot where Rick parked his car, his job was to keep an eye out for Rick. And if Rick was walking into the building with blueprints under his arms, he would get on the intercom and say, "The Pelican crows at midnight." Repeat, "The Pelican crows at midnight." Well, that was the signal for everybody who didn't really want to deal with Rick and his house project to close their doors or somehow get otherwise occupied, get in a meeting room, do something. I happened to be in the men's room at that point and I missed the call. All right. So I had my door open. Rick walks by with the blueprints under his arm, goes, "Hey, how you doing? Hey, you're here. You're never here, man. Every time I come by your office, you're never here. Can I show you something? I'm building a house. Did you know I'm building a house? I'm building a house. Here, let's get rid of all the crap you're working on. Let me roll out my blueprints and let me start asking you questions." And he's going on and on and on, asking about where should he put radiant floor heating here, about the plumbing, blah, 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 blah. And he says, he's going on just for free advice. So I'm looking at it, and I look at the bathroom, the drawing of the master bathroom, and there's this big 2-person tub here. And I says, "What's that?" And he goes, "It's a 2-person tub, man. I got a really good deal on it." He says, "Oh, what are you going to do with that?" And he looks at me and goes, "You know what I'm going to do with that, but chicka wow. That's what his plans were." I said, "Awesome. Good for you, man. That's terrific. What do you got for a water heater?" He says, "Oh, you're not going to believe this. The gas company's going to give me for free a 40-gallon gas water heater. How about that?" I said, "Terrific. What are you going to do with it?" I mean, if you use that, you're not going to use the tub. And he goes, "No, it'll be fine." He says, "No, it won't. The math doesn't work. You're not going to be able to fill that tub to the point where you can use it for what you have intended." And he goes, "Now it's going to be fine. We're not going to use it all that often." And I says, "You're darn right. You're not going to use it all that often. You're going to use it like never. You won't be able to fill the tub." And I couldn't get him to understand. He thought I just wanted him to spend money. And I said, "No, I want you to use the tub for its intended purposes, because if that is your wife, okay, if that is your wife trying to use the tub, this is going to be you. You're going to be taking a lot of cold showers and maybe jumping in an ice-filled Minnesota pond." So what was this problem? What was Rick's problem? He had a math problem, okay? It was arithmetic. That's all it was. A 40-gallon water heater was not going to fill up that big old two-person tub. Not no way, not no how. He didn't have enough storage, and he didn't have nearly enough recovery with just 40,000 BTUs. So what we're going to talk about tonight is how to interpret the data on these indirects so you know what you're getting, you know what's possible, and you know what you got to do to get what you need out of it. That's the most important thing. You're going to learn how to size the pump and how to size the pipe to back, to and from the boiler, from the boiler to the heat exchanger in the indirect and back again. Now, there's a bunch of different types and have different types of heat exchangers. There's tank and tanks. There's all different kinds. We're going to show you a basic coil type tonight, but you've got to size the pipe properly to carry the flow rate. Just because the tapping for the heat exchanger is 3/4 inch doesn't mean you have to run 3/4 inch pipe. You still got to get the gallons per minute flow rate to that heat exchanger. So you got to size that thing right. You got to size the pump properly. Okay, it's not always a 007 or anything like that. You got to know what it is you're looking at. All right, so we're going to show you how to interpret the data, size the pump and the pipe, and then show you a couple of interesting options that you can apply after the fact to maybe help out an underperforming indirect, how to give it a little bit of a boost, if you will. We'll talk about that at the very end. All right, how we doing out there, folks? Give me a little
They're doing
status check. Is everybody out there happy? And are we any questions out there yet? Or how's the pace? Let me get an idea. How's the pace going? Are we going too fast, too slow?
happy,
Everybody good?
happy,
Happy. Okay, we see a
smiling
few happy
face.
people out there. All right. And John McTaggart wants a T-shirt. Hey, you got to answer the question first. We got that. All right. Terrific. Everybody seems to be in a good mood tonight. Hey, it's Wednesday night. What's not? It's hump night, right?
It's hump
If Wednesday during the
day.
day is hump day, this is hump night, right? Anyway, let's look at some specs, shall we? Here's a spec sheet for Superstore. It's a brand. It's not we're not endorsing or not endorsing. It's just a brand that we're talking about. We have this spec sheet, and the spec sheet's pretty interesting. There's two charts. There's an upper chart for Superstore, and there's a lower chart. And you got to pay attention to both of them, all right? The upper chart gives you a lot of interesting stuff, okay? It tells you the model number. All right, obviously, you got to have the model number. And you scoot over a couple columns, it tells you the capacity. How many gallons, what's the size of the tank? How many gallons in that tank, all right? So 20, 30, 45, yada, yada, yada. So you've got all of those. You've got heat exchanger surface area. And then you've got these two columns, recommended flow rate and pressure drop. So they're telling you what flow rate you need to run to the heat exchanger from the boiler in order to get the rated output. You have to run a certain flow rate to that heat exchanger for this thing to do what it's supposed to do, all right? And then it's also telling you at that flow rate, the pressure drop through that heat exchanger is this. So let's take a look at the SSU 45 right there in the middle. The recommended flow rate to the heat exchanger is 10 gallons per minute. And at a flow rate of 10 gallons per minute, the pressure drop through the heat exchanger is 7.9 feet ahead. So if you're looking at sizing a circulator, you know right off the bat, in order to get this thing to work, I need 10 gallons a minute and at least 8 foot ahead, plus the supply and return piping to the boiler and whatever heat exchanger in the boiler I'm dealing with as well. So there's going to be more head than just the 7.9 feet. All right, so that's what that's telling you. Then it's giving you some ratings, 180 degree boiler water first hour ratings. And there's two columns. If you're storing at 140 degrees or at 115 degrees, why you'd store at 115, I don't know, but they put that there. And then 200 degree boiler water ratings if I had hotter water. Okay, had hotter water. What would that do? So you've got both of those there. So again, the top chart, as we said, the top chart is the happy chart. The top chart is life affirming. The top chart tells you everything is wonderful. All right, that you're a good looking person and you're going to do a wonderful job and everybody's happy on the top chart. Okay, everybody's happy on the top chart. So again, SSU 45. Okay, 45 gallon tank, 20 square foot of heat exchanger space. At 10 gallon a minute flow, 7.9 feet ahead through the heat exchanger only, all right? And then the ratings, 180 degree boiler water ratings, first hour. So that's the storage plus the first hour recovery. Storage plus first hour recovery at 140 degree, storing at 140 degree, that gives me 212 gallons of 140 degree water. If I go to 115 degree water, I got 292 gallons over that first hour. Okay, so that sounds like a lot of water, man. That sounds like an awful lot of hot water. I could fill a tub with that. That sounds like a lot of hot water. If I bump the water temperature up to 200 degrees, now I'm looking at 237 and 322. Well, glorioski, Captain BTU, what's not to like here, right? This all sounds pretty good. This all sounds really, really good, okay? So let's look, we got 45 gallons on hand, plus at 180 degree boiler water, we got a boatload of first hour hot water, first hour ratings. Now, does that mean you can turn that thing on full blast and it'll give you 212 gallons? Well, it's 212 gallons over an hour. Divide 212 by 60, and that'll give you the first hour gallons per minute, okay? Because there's 60 minutes in an hour. So that'll tell you that, all right? So what's not to like here? Well, the bottom chart is the chart that holds you accountable, okay? The bottom chart does not forgive your sins. The bottom chart is the very definition of the devil is in the details, all right? These are the details, and the details are sneaky here, because the first half of that chart's all a bunch of dimensional stuff that nobody pays attention to anyway, all right? You test pressure, working pressure, shipping weight, 88 pounds. Okay, note to self, I'll probably need help bringing it downstairs. But watch what we see way over on the right-hand side. In order to get those first hour ratings, you must have a boiler. For 180 degree boiler, 180 degree water, to get those ratings, 212 or 232, the boiler has to have a net output of 141,000 BTUs. And if you want the 200 degree boiler output, you're going to need a boiler with a net output of 161,000 BTUs. All right, 141 or 161. That's what we're looking at for those performance ratings. So now here's where the question comes in. Do I size the boiler for the domestic load or for the heating load? It's a really good question. And if you need 212 first hour gallons, if you need 212 first hour gallons, well, divide 212 by 60 and see what you got. If that's what you need, then that's what you need. Do you need that recovery? Could you go with the bigger tank? There's all kinds of different questions that we can ask here. Now let's take a look at this a little bit more closely, okay? If you have 141,000 BTUs at the boiler, all right? So remember, we got to first understand the tank itself. Now the tank itself, let's do some math here, okay? How do you figure out recovery? How do you figure out where did that 141,000 BTUs come from and why is it important? Well, we want to do the math, okay? To do the math to figure out recovery. This is how you figure out recovery. 141,000 BTUs, which is what they stated. To figure out your gallons per minute rate of recovery, you would divide the net boiler output by the product of 8.33 times 60 times 90. 8.33 times 60 times 90. 8.33, as we know, is the weight of 1 gallon of water. All right, 8.33 is the weight of 1 gallon of water. 60 is the number of minutes in an hour. We're trying to find out our recovery, rate of recovery. And then 90 is the DOE recommended temperature rise of the fluid. In this case, we're talking 50 degrees coming out of the ground, and we're raising that water 90 degrees, okay, to 140. So it's 50 degree water to 140 degree water, worst case scenario. Now, if you're in Alaska or Canada where the water is a heck of a lot colder than that in the middle of winter, you're going to have to adjust that number to see what you get. It's going to impact things because the water's colder, okay? You want to get the worst case scenario. So 141,000 divided by 8.33 times 60 times 90, we can actually simplify that just a little bit and round it up and call it 45,000. So if you're dealing with that 90 degree temperature rise, just to divide the net output of a boiler times 45,000, because 141,000 BTUs in this case, that's the amount of BTUs you have available to make domestic hot water, right? So 141,000 divided by 45,000 in this case will give us a rate of recovery of 3.13 gallons per minute. So this thing can recover all day long at a rate of 3.13 gallons per minute. All right, we're going to call it 3 just to round down. Okay, we're going to call it 3 gallons a minute. So this thing is capable of creating 3 gallons a minute of 140 degree water, 24 hours a day, 7 days a week, if that's all it had to do. Okay, that's all it had to do. Now, 3 gallons a minute times 60 minutes in an hour, my first hour recovery is 180 gallons. That's what I'm going to recover. It's going to turn cold water into hot water, 180 gallons over that 60 minutes. Now, remember our rating, first hour rating at 140 degrees was 212. Well, that tells me we're a little bit shy here. Where does the rest come from? Well, there's hot water in the tank, right? There's hot water in the tank. There's 45 gallons of hot water in the tank. Well, wait a minute. 212 and 180 doesn't make any sense, right? Do we have a question there, Rick?
No.
No.
I was going along with where you're going with that as a watch out.
Watch out. There you go.
There's more to that story.
Yes, there's more to that story. Absolutely. So I've got 180 gallons. My recovery is 180 gallons over that entire hour. I've got a 45 gallon tank, or do I? I do not have a 40. I have 45 gallons of hot water in the tank, but I don't have 45 gallons of hot water in the tank, if that makes any sense. How could we possibly explain that? Well, let's look at the math here, okay? You got to figure in any tank, especially an indirect and even a tank type water heater, direct fired water heater, about 75% of that capacity is actually usable at that temperature. Because what happens when you take hot water, you start taking hot water out of a tank? What's it replaced with? Rick, what's it replaced with?
That good old cold water, like,
It's replaced,
90 degree less, 100 degree less. Yeah.
It's cold water. You take the hot water out, you put the cold water in. It's the BTU hokey pokey right there.
Hokey pokey.
Bingo. So you get about 75% of that is usable capacity. And again, that's the cold water coming into replace, and also the coil takes up some space. There was some cubic footage area for that coil that does take up some space in that 45 gallon tank. So let's figure this out. 45 gallons times 0.75, which is an approximation, okay? It is an approximation. That tells us really we have 34 gallons worth of hot water there ready for a dump, okay? Ready to just dump right into whatever it is. So I've got 34 gallons available, plus the 180 gallons over the first hour for recovery. So we math that out. Again, it's all about BTUs and GPM, right? How many gallons per minute can I make with the BTUs available? So I've got 100, what I have is 180 plus my 35 is going to give me 34 is 214 gallons over the first hour, right? 214, the spec sheet said 212. Hey, we rounded up, we rounded down. That's well within the range of where those numbers came from. So now I got to figure, I got 34 gallons to dump. What's my gallons per minute flow rate at that fixture and at what temperature? Because you're not dumping 140 degree water into the bathtub and taking a bath in it, not twice anyway. So yeah, we're going to temper that down to maybe what, 107, 105. Okay. I've got 34 gallons there of hot water. I'm mixing it with some cooler water. I'm going to fill a lot of tubs with this thing. Am I going to fill a 200 gallon tub really fast so I can take a bath right away? Probably not, but I can fill a regular bathtub, and I can probably fill a good sized whirlpool or jetted tub with that. Would you agree with that assessment, Richard?
Yeah.
Cool. So again, figuring recovery, it's all about BTUs and GPM. How many GPM can I make with the BTUs available? All right. Cool. Do we have any questions out there, guys? Any questions that I need to be taking a look at here? Are you guys all getting it? All right. There we go.
Comments?
Okay, here's one. Wiesmann used to have us double the size of the indirect as the boiler temperature was limited to 163 degrees. Yeah, you'd have to make it bigger because they were talking about 180, maybe 190 degree water in the boiler. But again, it's all about BTUs, okay? And, experiences domestic rules, even in the mountains. Sure, absolutely. So yeah, there's a lot of things to look at. We're going to show you what you might be able to do how would you approach this if your heating load was less and you wanted to size the boiler to the heating load? What would that do to your recovery? That's going to be an interesting thing we're going to take a look at right after we do our Takeo trivia question of the night. And look who has shown up.
Just in time.
Dave's not here, man. No, Dave's here. How are you, Dave?
Dave's here, man. Yes, I am well. Sorry for tardiness here, but you can't just leave the kids anywhere in the laying around and stuff like that. You got to go get them back home. So
No worries, but you don't get fruit cup. All right, you ready for the Takeo trivia question of the night from the Ferris Bueller's Day Off? All right, and here's the question. Now, the role of that droning economics teacher, Bueller, anyone? Bueller, was played by Ben Stein. He was played by an actor named Ben Stein. Now, before his acting career, what was Ben Stein's most notable occupation? What was Ben Stein's
Wow.
most notable occupation prior to his becoming an actor?
Wow.
He was a thespian second. He was something else before that. What was that occupation, and for whom did he work? These are all interesting things. They say when you go to Takeo After Dark, you just don't learn about plumbing and heating and hydronics and math and all this. You get the information any well-rounded couch potato needs to fully enjoy their life in front of the big screen TV. All right, very good, very good. Let us continue. All right. Now back to work. So we have our 34 gallons stored, our 180 gallons recovered. That's 214 first hour gallons. So if we wanted to figure out our gallons per minute first hour, 214 divided by 60, that's about 3.5 gallons for that first hour, 3.5 gallons per minute for the first hour of 140-degree water. Now remember, we're tempering that down to about 105, maybe thereabouts, whatever it is you take a bath in or take a shower in. So you gotta figure we're pushing availability of at least 4.5 gallons per minute. We can take a nice long shower and not have to worry about it. We can take a shower after a shower after a shower and maybe not necessarily run out. Can a bunch of people take a shower let me rephrase this because it might come out wrong. Can a bunch of people take showers at the same time in different bathrooms? That's where we want to go with this. Possibly, maybe not. It depends. That may be the limiting factor that's going to run this thing out. Now, again, you guys know your customers. You know in Colorado what rules the roost. Does domestic hot water rule the roost? Yeah. If you've got a customer that says, I don't care about anything, I never want to run out of hot water, or it's your buttocks on the line, okay, biggest tank you can find and size to the domestic load. All right. I mean, how reasonable can you get? I mean, are they going to build a car wash kind of shower stall with like 47 nozzles? So they can shower with 7 of their closest friends. Hey, if that's what it takes, that's what it takes, right? You got to look at the specs and see what they require. So that's how you kind of interpret all of that information, okay? But this is a big if. That 3.5 gallons per minute is what's possible, but there's some things you got to do, okay? The conditions, the things that hold you accountable. First off, again, you need that buck 41 boiler, all right? The boiler piping has to be done properly. It has to be sized right. Everything's got to be in line, and the circulator has to be chosen properly. You can't expect to get this and pipe the Indirect's heat exchanger up with 3/4 inch pipe and then put a 007 on it. See, a lot of people do that. Figure, well, it's supposed to work, right? No, we're not doing it properly. That's why we went through the spec sheets. You've got to look at the numbers and basically let those numbers lead you. So we said earlier, 10 gallons per minute. You needed 10 gallons per minute, all right, through that heat exchanger. What size pipe do we need, Rick, for 10 gallons per minute?
You could, depends on how short that pipe is, you could do 1 inch, maxing out 1 inch type L copper, but if you're unsure, you'd go to the next size for 1 1/4 inch.
Yeah, I mean, 1 inch is about as minimum as you'd want to go.
Yep.
1 1/4 inch would probably be a better choice. And let's say it was, we had 10 well, we'll walk through the flow and head calculations here in a minute and circulator selection. But as we do that, I also want to show you what the math looks like if we said, you know what, I'm sizing the boiler for the heating load and I'll figure it out, okay? I'll figure it out with a smaller boiler. If I'm going to use a smaller boiler instead of that 141, let's say the boiler, again, we go back to our equation. Net boiler output divided by 45,000. That's how you'll find your rate of recovery. Okay, the usable capacity in the tank still stays the same. In this case, about 34 gallons, right? But now we got to figure out what's the rate of recovery. How many gallons per minute can I recover with the BTUs I have available? So let's say I have a boiler that has a net output, and this is your DOE output or your net output of 75,000. So 75,000 divided by 45,000, you can see what's happened to my rate of recovery. It's cut almost in half down to 1.67 GPM. Multiply that by 60. Now I'm down to 100 first hour gallons worth of recovery. So I've got 100 first hour gallons, or 1.67 per minute, 1.67 per minute. What does that mean? Well, 34 gallons stored plus the 100 gallons recovered. All right, now we're talking about 134 first hour gallons and a first hour flow rate of just a little bit less than 2.25 gallons per minute. But again, 140-degree water, we're tempering down to whatever it is at the fixture itself. We're going to have a broader, we're going to have a much more than 2.5 gallons per minute available at the fixture. We can take a shower, okay? We can take a long shower, and then someone right after us can take a shower. So that's kind of where that's the trade-off we're making here. Is that going to be adequate for the application? Do I need a bigger tank? There's another way of looking at it too. Should I put in one of the larger tanks for more storage? Okay, that's a way you would look at it. All right. So the question you ask is, are we okay? Is this going to satisfy the needs? Do I necessarily have to put in 141, or can the 75,000 BTU boiler work? Depends on the structure. Depends on the structure. Now, pipe sizing, again, we go back here and we saw 10 gallons a minute, 7.9 feet ahead. All right, if the stars are aligned and if the moon is in the 7th house and Jupiter's aligned with Mars, peace will guide the planets, love will steer the stars, and you can use 1-inch pipe. All right, if it's kind of out of the way, you might need to go up to 1.25 inches, even though the connection is 3/4 inch. Now, how the heck, guys? Dave, let me ask you. Why the heck would I run 1.25 inch pipe if that hole is only 3/4 inch? That makes no sense whatsoever.
Because it tells me so in the RTFM.
And yes, in the manual, that's right. It tells me so. And why will it work? Why do I need to run 1.25 inch pipe?
For this example, for this tank here, because it's looking for 10 gallon a minute flow. All right, and safe, trouble-free design, velocities, everything like that. You want to have 10 gallons a minute flow. And could you get away with 1 inch? Yeah, kind of, but I would recommend doing the 1.25 inch for the 10 gallon a minute flow there.
But what about the connection, man? The connection's 3/4.
Oh,
Isn't that just make it a 3/4 inch everything? I mean, you can't put 1.25 inches worth of flow through a 3/4 inch hole, can you?
sure you can. It's just going to be a pressure drop. The velocity increases right there at that connection. It's a pressure drop that we have to add on to the pressure drop of the coil.
Right. It's like putting your finger over a portion of the hose at the end, right?
Yeah, you ain't stopping the water flow. No way.
Yeah, that's right. Yeah, it's a lot of people say, well, it might as well just make it only 3/4 because I'm turning it all into 3/4 inch pipe. No. It's velocity. It is pressure drop. You still got to get 10 gallons a minute to it. That's the bottom line. You got to get 10 gallons a minute to get the ratings we see here. There's the important part, to get the ratings we see here. So the recommended flow rate is 10 gallons a minute, and the coil head loss is 7.9. However, that's if we're doing 141,000. However, we have a 75,000 BTU boiler. Does that change the equation any, Richard?
Yes.
It does. It does change the
It
equation.
do.
It does and it do. We got to figure out our pressure, our actual flow rate here. Because typically, remember we've talked about this dozens of times, that we design hydronics to a 20-degree delta T. However, indirects are generally rated at a delta T of 30 degrees, okay? A little wider temperature drop across the heat exchanger, all right? So let's figure out the flow rate. To get 75,000 BTUs out of the boiler and into the indirect, all right, I need a flow rate. So 75,000 BTUs divided by, remember our universal hydronics formula. Together, gang, what does the universal hydronics formula tell us? It tells us that GPM is equal to BTUH divided by the product of delta T times 500. So BTUH 75,000 divided by the product of delta T times 500, 30 times 500, all right, is going to give us a flow rate, a required flow rate of 5 gallons per minute. 5 gallons per minute. Now we can get into what does that do to the pressure drop? Well, the flow rate is half. The pressure drop is actually going to drop by 75%. Okay, that's kind of how that math works. If you ever want to see where that comes from, grab a B&G system sizer wheel, go to scale number 5, and figure out a system curve. All right, which is, again, we can talk about that at the end of the presentation, but that's how you'd figure it out. So at 5 gallons a minute through that coil, at 5 gallons a minute, that coil will impart 2 feet of pressure loss, or 2 feet of head. So dropping that flow down actually has a bit of a benefit. 5 gallons a minute at 2 feet of head. All right. Is that clear to everybody? Yeah.
Can I point something out?
Please do.
If you rounded that coil head loss up to 8 feet, which is pretty close, right? And what did you just say we came down to? We came down to
2 feet ahead.
So look at the relationship there. And we talk about things that are cubed. So as flow increases, the head increases. So that's dead nuts on as far as rounding is concerned. We went from 8 down to 2 because we cut the flow in half.
Right.
So there's a correlation there when you do this, and I don't have this stuff all memorized, but once you do these calculations over and over again, you start seeing this relationship, and it goes back to just what happens with pressure drop in a system when we start playing with the flow. And this goes right down the line with our circulators. If you keep a circulator on a fixed piping system, and you start playing with the flow, we can predict what the new pressure drop is. And just wanted to show that relationship.
Simply stated, and I think Rick make a really great point. In this example, 5 gallons a minute at 2 feet ahead, 10 gallons a minute at 8 feet ahead. In this case, if you double the flow, the head loss is cubed. 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. Yeah. Double the flow, the head loss increases by a cube.
Yeah.
Very good. Isn't math wonderful? It's almost like there's a science behind this, right?
No, you can do a class without math. I did it last week.
Yeah. Who let you in? So what does this mean? 5 gallons a minute, we're looking at 1-inch pipe. Again, could you do 3/4, Rick? Could you do 3/4 for 5 gallons a minute?
Yeah, I'd always look and see which type of pipe and size of pipe, but yes, you could, but you're kind of on, again, if it's a real short run, then I typically would use 3/4 for 5 gallons a minute. But if it's a long run, I just look at what the resultant pressure drop is before I choose the pipe size.
Right.
Okay. I know what I want to try to design around. So I take that into consideration.
Very good, very good. So in this case, yeah, we'll be safe. We'll use 1-inch pipe, okay? And let's figure this out. I've got I figure the total equivalent length, all right? That's the length of the pipe times 1.5. Okay, the supply and return. We're gonna ballpark the head here. I'm gonna measure from the gazouta side of the circulator all the way through to the tank, back from the tank, back into the boiler, and back to the gazinda side of the circulator. That's going to be a certain length of pipe. And then I'm going to multiply that by 1.5 to allow for valves and fittings and stuff like that. In this example, I come up with an equivalent length with all of the fittings taken into account of 80 feet. Then I'm going to multiply that equivalent length times 0.04. which represents 4 feet of head loss for every 100 feet of straight, properly sized pipe. So if you want a real quick way to estimate the head loss on the high side, it will always be on the high side. Measure the length, multiply by 1.5 to allow for fittings and stuff that's in the way, and then multiply by 0.04. Doesn't matter what size of pipe it is, it's always 0.04. So whatever the measured length times 1.5 times 0.04 will estimate the head loss through a piping circuit on the high side. You will always be safe here, man. Always be safe. In this example, we're looking at about 3.2 feet of additional head. All right, 3.2 feet of additional head. So in this case, if I add the 2 feet ahead through the coil plus 3.2, I'm looking at 5.2 feet ahead overall in terms of pressure loss to go along with the 5 gallons per minute that we were looking at. All right. So I need to move. My circulator needs to be sized for 5 gallons a minute at 5 feet ahead. Okay, that's actually pretty reasonable. I could do that. There's a lot of circulators that can make that happen. A lot of circulators. If we take a look at just your basic 3-speed, the 0015 standard efficiency 3-speed. Now, if I was to do this with that 10 gallons a minute, all right, 10 gallons a minute at 7.9 feet ahead plus the additional 3.2 feet, I'm looking at about 10 gallons a minute at a little over 10 feet ahead. Look at that. It's right on the edge. It's right at the high speed of a typical 3-speed circulator. So that would work. I could use that circulator, but I'd need to put it to high. All right, I'd need to put it to high to make it work. If I was going with the smaller boiler, 5 gallons a minute, 5.2 feet ahead, well, looky-loo, that's where it's going to work at low speed. All right, it's going to work at low speed, right about there. So I could use the same circulator. I don't need to put it to high. And in fact, Rick and Dave, should I put it to high just to be sure? What would happen in this example if I did?
Dave?
Any guesses?
Actually wasn't listening. I'm typing names.
Oh,
Okay.
Dave's having his dinner right now, I think.
No, I'm doing the wheels here. I'm looking at all the questions.
Oh, you're a good man. You're a good man.
Yeah.
Well, look at
good
it
man.
this way. If I
So,
needed
sorry, I
5 gallons a minute, and I'm pumping 10, what's gonna sacrifice? What am I gonna lose out on? What's gonna be smaller than maybe we would hope it would be?
Delta across the heat exchanger of the boiler.
The delta across the heat exchanger of the boiler, and the indirect, right? So
Yeah.
instead of a 30-degree delta T across the heat exchanger of the indirect and across the boiler, it's going to be 15, right? So I may start to short. I'm going to encourage this whole thing to short cycle, and I'm going to use a lot more energy than I need to. So in this case, it really does behoove you to do a little bit of math, doesn't it? Now you know. And if you were going with ECM, you could use the Takeo 0015 E3 and set that to low speed, and maybe be able to make this thing work at 30 watts instead of 85.
There you go.
So there's the secret behind doing the math. We're going to make the boiler work better. We're going to make the indirect work better, and if we do it right, we'll use less electricity. Even a standard 0015 at low speed is going to use considerably fewer watts than a 0015 at high speed. All right. So that's how we always make use of the math to help us make these good decisions when it comes to the most important element of the system, which is the circulator. So, cool. Very cool. All right. How we doing, folks? Any questions out there we need to jump into?
Thanks on the photo. Not so great. Somebody's got some opinion there for sure.
Oh, that's all right. Hey, I just grab pictures, man. We're not endorsing product. We're just grabbing pictures. All right.
That's right on.
There you go.
Yeah.
All righty. Very good. Very good. Okay, great. Hey, now I told you before that I'd show you a little trick that might be able to help you out in a pinch. All right, and maybe help an underperforming tank perform up to expectations. And we're going to use a tempering valve. We're going to temperify, man. We're going to use a tempering valve or a mixing valve. Okay, and the mixing valve you're looking at that's the second product Takeo ever made. Back in 1920, we introduced the world to sidearm water heaters. All right, these little copper coils inside of a big old cast iron casing, and the boiler water went into the cast iron side, and the domestic water was in the copper coil, and it was an original indirect water heater. If you think about it, it was an original indirect water heater, and those things rocked, man. Those things worked great. You know how great they worked? They made buttloads of scalding hot water. Seriously scalding hot water, which led to the development of the mixing valve. All right. Okay, let's dial it down a little bit, guys. Let's figure out what we got to do and let's dial it down. So Takeo introduced in the mid-20s the mixing valve to temper the water so we wouldn't burn people. So the tempering valve helps. The tempering valve helps an underperforming indirect to perform to higher levels. And it's good for any tank type water heater. It'll do the same thing for any tank type water heater. What it
Hey,
does, yes,
hey, John,
yes.
maybe, and this is for my edification as well. Isn't this the device that caused us to change the name or shorten the name? There was room on the first device. There wasn't room on this device. So show them what I'm getting at right there, because I thought it makes sense to me.
There you go. All right, brief aside, brief aside. A lot of people want to know, where'd the name Taco come from? How come you name your company after a Mexican treat like a taco? Well, we didn't name it after a taco. All right. And if you and I got a buddy in Minnesota that I used to work with, and he when he wants to bust my chops, he goes, "How's things at Taco?" I said, "Oh, Brad, please." But no, the original name of the company, when the company first started, it was called the Thermal Appliance Company. And on a sidearm water heater, it's a big thing, man, and there's a lot of room on the cast iron casing to cast in the full name of the company, the Thermal Appliance Company. All right, so you had a lot of room there. Now you'll note that the mixing valve is a lot smaller than a than a sidearm water heater, and there wasn't enough room to put the Thermal Appliance Company on there, so they had to shorten it, and they shortened it to Big T, Big A, Big C, little O. Basically the initials, Thermal Appliance Company. Now, people saw that and they didn't automatically go to Taco because unless you, back in the 20s, unless you were living maybe 50 miles from the Rio Grande, you didn't know what a taco was. Never heard of a taco. Nobody thought to call it taco. They just said, what's a taco? Oh, that's the name of the company, Taco. Nobody thought to call it anything else. And that's how the name came. That's, if you're ever on Jeopardy and the category is origins of hydronic heating manufacturers for 60, and it comes up, this is the origin of the Thermal Appliance Company, then you'll know. Or this company started as the Thermal Appliance Company. What is Taco? And then ding, 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 the daily double, and you win. So
Winner.
winner, winner. There you go. That's how. What did they call those? The just so stories when you were a kid? That's how the elephant got a long nose and all that stuff. Yeah, that's how Taco got its name. So the tempering valve actually makes the tank think it's bigger. All right. And there's a math formula for it. That's what I love most about this, Dave, is there's a math formula for this. And what makes it even better is it's a two-part math formula. So get your math geek on, baby. There's two parts to this. The first part is we have to find something called the storage factor. All right, the storage factor, which we're going to use in the second part. To figure out the storage factor, you do that little math formula, which it says T mix minus T ink. So T mix, that's the temperature of the water coming out of the outlet, the mixed temperature, minus the T ink. That would be the water coming into out of the ground and coming into the cold inlet right here, okay? That's the water going into the cold inlet, all right? Divided by the temperature of the water being stored. That's the water coming in right here, right? That's the hot inlet, right? That's the hot inlet. That's the temperature of the water being stored. So I'm mixing some of this with some of this, right? To get whatever it is I want out of here, all right? So T mix, that's what I want here. That's the outlet temperature minus the T ink divided by T stored minus T ink, all right? So T mix, that's the outlet temperature, that's the temperature I'm sending out the fixtures, minus the incoming water temperature, divided by the temperature of the water stored in the tank, minus the temperature of the incoming water, is going to give me something called the storage factor. Storage factor is only meaningful, and then I'm going to use it in the second half of the math equation. So let's create some capacity. Let's say I am mixing, my mixed outlet temperature is 112 degrees. All right, there's a reason I picked 112. We'll discuss it in a minute. 112 degrees minus the 50-degree incoming water. So 112 minus 50 divided by the temperature of my stored water, 140 minus 50, is going to give me my storage factor. So let's simplify. 112 minus 50 is 62. 140 minus 50 is 90. So 62 divided by 90 gives me a storage factor of 0.69. That's my storage factor, 0.69. Now, to figure out the tempered capacity of the tank, I simply divide my usable capacity by the storage factor. All right, the usable capacity by the storage factor, that equals my tempered capacity. So in this example, I've got 34 gallons of usable capacity. My storage factor is 0.69. 34 divided by 0.69 gives me a tempered capacity of just over 49 gallons.
Yeah.
I've basically boosted the capacity of that tank by 50%. All right. So I'm getting 49 gallons of 112 degree water out of the tank. I can further temper it at the fixture. All right. Further temper that at the fixture if I so choose to. All right. That's one way to do this. Now, Dave, you do this way better than I do. Take a break from your spinning wheel and explain why we had 112 degrees as our outlet temperature in this example.
All right, in this example, so this is something kind of important to pay attention to when it comes to mixing valves, and it's not necessarily just the take-off valves that we have out there. What you've got is that thermostatic element on the inside that's reacting to a temperature difference. And the reason why we chose 112 degrees here is because the storage temperature was 140, and we want to see a minimum of a 27-degree spread, and that's going to help that thermostatic element operate the way it's supposed to. These things come set for 120 coming out of the box, and if you leave your tank at 140, you get a little sandwiching that's going on. It's not getting the right opening and temperature control that you want to see out of it. So you want to watch that with the temperature settings. Now, some of them are less. We have valves that go down to 10 degrees. I've even seen other brands go down to 5 degrees, but make sure you pay attention to that differential temperature that it's looking for. So that's why this example says 112. Every time I show this too, people look at it saying 112. No, that's way too cold. I got to jack it up. Or if you have a storage tank, you set it for 120 and you got the mix valve for 120. It's not a lot going on there. A lot of differences happening, so you're not going to get the operation of the valve. You're not going to get the flow that you're looking for. And then all this math that we did is out the window.
Very good. Very good. So yeah, check the valve that you're using. We have them that require that 27 or so degree differential. And we also have the ones that require just a 10-degree differential. And that gives you a little bit more leeway. So you can adjust that. Maybe we would adjust it down to 120 on the outlet side at that point. So that's a way to enhance the performance of that indirect, to get a little bit more out of it if necessary. But what if we really decided to push the old envelope? I mean, really get crazy here, okay? What if we really wanted to get crazy? And we decided to go completely nuts and store the water at 160 degrees, all right? We cranked that up and stored it at 160 degrees. And we were still doing the 112 degree thing. We could do 100, in this case, we could change it to 120. That's not the point of this. The point is just to see what would happen if we boosted that water temperature up to 160. So in this case, 112 minus 50 is 62, 160 minus 50 is 110. That gives us a storage factor of 0.56. Now, 34 gallons divided by a storage factor of 0.56, that gives us a tempered capacity in that tank of 60 gallons. And that's the same basic usable capacity as an 80-gallon tank. So what we've essentially done here is we've turned a 45-gallon tank into an 80-gallon tank, all right, with 112-degree water coming out. If we stored it at 120, it would be less, but it would be less than an 80-gallon tank, but it would still be a boatload more than what we were getting out of that tank in the first place, if we needed to. All right. So that's how you use the mixing valve to your advantage, and that's the math behind it. So if you want to enhance the output, if you find that you need to and enhance that output, you can certainly store at a higher temperature. Nothing says you have to store it at 140 or 140, but you darn well better make sure you've got that mix valve on there and dialed in so you don't scald anybody.
And I like that too also, because this is an instance where you can become a hero to a lot of our customers that we come walking into their house, right? A lot of, when they see us walk in the door, what do they see afterwards, right?
Money leaving.
Yeah, a bill on the table. So this is something that if you do a little exploratory with the homeowners, meaning if you're already there doing some work one day, hey, does this happen to you? Do you seem to run out of hot water? Do you not have enough? Does it not maybe feel hot enough for you? Ask a couple of questions, and then say, well, all I have to do is I'm going to put this mix valve in for you and get you what you wanted. And this is something that they didn't know. This is something that they've lived with for many, many years. They didn't know that this can be fixed. They just said, hey, this is the way it is. And it's not supposed to be, right? So let's make sure we get them the water that they're looking for, get them the temperature that they're looking for. You get them the safety behind it too, that the mixing valve is going to get you. But the biggest thing is getting them the numbers. And I have this exact example in my house going on right now. So the house I'm in now was a family of 2. All right, it was my in-laws' place. Then we did some renovations, put an addition on, and it became a family of 6. Spent enough money in making the house a family of 6, and I had a small 30-gallon tank in there. So instead of having to swap out the tank and putting an 80-gallon in, where my boiler room is a closet, and if I put an 80-gallon in there, I've got stuff on the walls I'd never see again. I got a manifold and circulator back there and controllers that I'd never get to. I'd have to pull the tank in order to service any of that equipment. So I kept that tank in there, and I run about 165 degrees in my tank, and I have about 120 going out, and I get all the hot water in the world.
Very good. Very good. Excellent. Well, I hope you guys enjoyed this. Shall we do the trivia answers now, Dave?
So I saw 2 questions flying around out there, so I have
let's
to ask
let's
which
grab
one's
those questions
which.
flying around out there. Let's get those.
What was the first one? I guess where Rick is, or who somebody was somewhere?
Somebody who and what?
It wasn't Rick. Rick opened his big mouth though, so I'll take that blame. I just
Okay.
threw it out there.
Did you do a Where's Eric again?
Yes, we did a Where's Eric.
I had
did
never
do-
done a Where's Eric, so I come into this blind and I opened my big mouth. So that's why
that's
you got
all
so many
right.
people got that one right.
Well, then I should have had
Sorry.
100 names out there, but I did not get it. I didn't get
No,
it.
we just hey, and the correct answer, just so everybody knows, Eric was in Machu Picchu, Peru. Machu Picchu, Peru, which is I would love to go there someday. That looks really cool. I'll have to ask Eric about it next time I see him. So Dave, you got to do 2 wheels, one for Machu Picchu and one for the correct answer. And do you know the correct answer? Because you did this to me a couple weeks ago. You didn't give me the right answer, and I had to scramble at the end.
I did look it up, and I did kind of know it already in the background. And you know what? There was a lot of wide answers on that. But let's do the Machu Picchu. What am I giving away for T-shirt for this one, right?
T-shirt.
T-shirt for
It's like
Machu
this.
Picchu. And let's tell him the answer to the regular question though too. All right.
Okay.
You took it away from me, didn't you?
I just took it away. Yes, I did. I'll give it back
People,
to you.
do you see what I have to
Damnable.
deal with here on an everyday basis?
Hey, are
All
we
right.
gonna hug and kiss when we finally get together?
Well, we may
I may be fired, man, when I get
from a
you back
distance.
together,
I don't know. All right. Let's see. Okay, the trivia answer to our question, what was Ben Stein's job? Biggest headline job before becoming an actor. He was a speechwriter for both Richard Nixon and Gerald Ford. He was a speechwriter for Richard Nixon and Gerald Ford.
Some people
So I
got that.
got that. There was quite a few answers for that one too, but a lot of answers came in as economist.
Actually,
That gets confused a lot of times because that was his father.
what I
His
got
father was an economist.
when I looked it up, I got poverty lawyer.
A poverty lawyer.
Lawyer.
Oh,
Yeah.
Interesting.
Well, he's talk about a guy who's had a few quirky career twists. I thought starting out as a DJ and then becoming a plumber was a little weird, but hey, speechwriter for Nixon and Ford turned comic actor is pretty good too. Maybe a more natural progression. I don't know, but there you go.
It could have been easily just rolled right into that. Yeah.
There you go. There you go. So Ben Stein was a speechwriter for Richard Nixon and Gerald Ford. So that's the correct answer there. So excellent. All right. So that's a wrap on that show on the Indirect. So as always, we're gonna just hang out, man. We're gonna be here forever to answer your questions. But are you ready now, Dave, for the spinning wheels?
I am ready. I will
All
take it away now again.
Okay, now you can have it.
Thank you. Thank you. All right, let me pull this up. Bing. There we go. Making sure it's on the side. All right. So this is for Machu Picchu that Rick gave the answer to. So I should probably just send everybody a T-shirt, right?
If you got enough.
Hey, you guys remember
Tell you
where
what,
you
how many can we give away two? Let's give away 3 T-shirts. All right, for that
2
one.
T-shirts. All right.
3 T-shirts. 3 T-shirts. Executive decision.
Gustavo.
Gustavo. All right.
Solano.
I will
Gustavo
contact,
Solano,
and what I'll do is I'll contact you all offline in an email to look for your shirt size and also a mailing address. All right, let me do the second spin here.
Like a wheel, I'm gonna spin it. With words to a song, you tell me what they
Bill.
are.
Too funny, Bill.
All
So-
right.
William.
Congratulations.
And he commented, he's like, I won one last year. That's okay, brother.
So you got another one.
And he kind of was like saying, I don't want another one, but you got one, so you could sell it. You could do whatever you want with it. Hit eBay on it. So
They are in demand. I will tell you that. They are in demand.
and the third shirt, Doug got close to you again, man.
Oh, Andrew.
Andrew.
And I
All
think
right,
I
Andrew.
typed your name incorrectly, but I'll take a look at that, Andrew.
Very good. Congratulations. All right. Excellent. Excellent.
All right.
And now you
All
too
right.
can wander around and everyone will know that you are a fan of the hottest, longest running hydronic plumbing webinar series on the internet with a worldwide audience. People will look at you and they'll go, aw.
John,
That's right.
explain to them what you mean by worldwide, because I'm sure they don't know.
Oh, worldwide, we get people from all over the world. We've had people from Australia. We have people from the Middle East. We have people from South America. We have people from all over attending our Takeo After Dark presentations, and we're
It
thrilled
blows
to
me
have you.
away.
And hey,
Blows me
anybody out there from lands afar, please chime in and let us know where you are from, because we love having you. This is the world's getting smaller each and every day.
It is,
right?
no doubt.
All righty. So if you can guys type that in just for our own interest, because we'd like to know. And are you ready? Are you ready with the what's our big prize anyway tonight, Dave, for the trivia?
Well, that's what I was going to ask you, I think.
You're the one who has the prizes.
I know. I gotta, so I know I got boxes of T-shirts down there that I gotta get rid of. So, but the grand prize, let's see. Oh, I know what I got downstairs. I have a portable Bluetooth speaker.
Oh,
Nice.
Yeah, yes.
Oh,
And,
it says Takeo on it, right?
It does. It
Or
does.
does it
Not
say
just
thermal appliance
one that
company?
was, laying around in my house, that I gave to my kids or something like that. So, so yes, it's a Takeo Bluetooth speaker, and of course other accessories that I've got down there. I will give away tonight. So
All
with
right,
that being
terrific.
said, here is the wheel of everybody that got speechwriter correct.
And why am I not surprised to see Travis Ball there? I mean, Travis, you win everything. Travis has an
He's a
entirely
smart dude.
wardrobe. He won a new car. I mean, what else did you win from us, Travis?
I know he's quick on that. Either one, he's just got a mind that holds everything like a steel trap,
You
or
know
he's
what?
quick. What's that?
Peter's on there too, and I'm just a Mayo, but he's D Mayo.
That's right.
That's even better.
Peter's been a
Hey.
winner in the past too. He's got some. He's
know.
won some
I've
stuff from us in the
seen him
past.
on
Yep. Yep.
All right, spin that bad boy. Let's see what we got.
And it looks like I'm the winner.
Spin again, my
no,
friend.
No.
Spin again.
I'll have to
No.
remove it. All right.
Get it out of there.
So it looks like we got people from Texas and Canada and New Jersey.
Look at that.
Oh, shocked. I'm shocked. I'm just shocked.
Travis.
Travis. Nicely done, Travis. Congratulations. Now you can outfit your extended family, I think.
Yes.
You got clothing now for a second uncle on your mother's side, I believe now. It's a distant
And I
cousins,
did get your email, Travis. Thank you.
All right, very good. We got Rigby, Idaho. We have
Rigby, I know people in Rigby. Mike,
How do you, yeah, Barrett asked, how do you get your name on the wheel? That was for answering our trivia question correctly. So that's how you get your name on the wheel and how you win stuff. Hey, you ask a good question, you should probably get a T-shirt for that, right, Dave?
That's right.
All right.
That's
Yeah.
right. I usually go through if you are, and that was a question there, Barat, so when we get questions and comments and things like that, I also go through the lists tomorrow, and if it really looks cool or it was interesting or it was fun or whatever it is, sometimes I just do randoms and I just send stuff out to people too. So just to say
that might
thanks
be
for hanging out.
right there. I know you're right. All right, very good. Here's why I like this one from John McTaggart. I work in the high Arctic, Resolute Bay. If you send me an XLT, I will pose holding a Takeo in a cold, snowy tundra, holding a Takeo pump, and send you guys the pics. Can't argue with that.
hey, John, only if the northern lights are exposed.
Well, yes. Get the northern lights up there, and it's a deal.
Borealis.
I went to summer camp once with a kid, and he used to call himself Aurora Borealis. I didn't know what it meant. I was like 11, and I remember asking him, "What's your name, man?" He goes, "Aurora Borealis, so you better watch out." Scared the hell out of me.
You never forgot it.
I never forgot it. Aurora Borealis, so you better watch out. All right, I did. All righty. Well, hey, now is the time for us to. It's open forum time, folks. We finished our main presentation. So, any questions that you have on that? Any further questions you have on that? Please. Now is the time.
I'll grab this one from
Okay.
Kerry.
All righty.
So he's talking about this. It's a buzzword, electrification. Dave's into this because of what we're working on. We haven't come out with it yet, right, Dave? But an electric boiler that just.
So let's preface it before you go any further, Rick. So nobody else can see the questions yet, right? So Kerry asked it, with electrification coming, how do electric boilers compare to gas and propane boilers? So
Yeah, good. I should have clarified that. But
that's okay, brother.
Electric boiler doesn't do anything from the standpoint of other than converting that energy and putting it into the water. You're going to pay whatever kW you're charged for that energy, which is okay depending on where you're at. There's a bunch of people on this program that including us and everybody else on this list, that pay a boatload of money for electricity. What we want to talk about is how can we get more energy than what you're paying for. Put it this way, if I got $1 worth of energy straight across, or I got $3 worth of energy for $1, that's when we start talking about this coefficient of performance, COP. So devices like air to water heat pumps, ground source heat pumps, and things like give us more energy for $1 worth of energy than you would get on a straight cross. Electric boiler is nothing more than a straight cross. So understand that with electrification, we got to get more bang for our buck, and we're going to get that with something like a heat pump. So Dave has been tasked with some things, and we can talk about it, right? We showed it at a couple of shows already.
Oh yeah.
Right? Yeah, okay.
Yeah, absolutely.
Yeah. All right. Dave, I pass it to you.
Oh, well, I haven't worked on it too much because it's still before
in the works.
Yeah, it's not even ready to hit my desk yet. So for what Rick is talking about, we are in development of our own heat pump system, an air to water heat pump. So we've been working on it for a little while now. We've partnered up with the outdoor unit from another company, and also bringing it inside, and we're developing and designing the indoor portion of the system also. So it's a pretty neat system that we can do, in getting us the hydronics that we all love and want to have in our homes, but now getting rid of burning fuel and going to the electrification of things. So it is a pretty neat setup so far from what I've understand. I haven't been able to hang out with them just much as yet because we have a couple of beta sites out there. I don't even know if I can call them beta sites yet. Maybe I can call them alpha sites, right? We haven't even gotten to the beta stage. So we're still a little away on doing it. Kevin, it's really residential right now. We're looking at about 50,000 BTUs of hydronic that we can get out of it. So it's not looking at what we're looking at, what we're designing. Yeah, it's going to fit your 2,000, 2,500 square foot home in a lot of projects. It's going to get you, your air conditioning, and it's going to get you also domestic coming out of it too at the same time. If we would apply it commercially, you may have to use several units in order to get the more BTUs. But looking at a 50,000 BTU unit, I'm sure you don't want to do too much on that commercially. From ourselves, anyhow. I'm sure there's other companies that are making it.
Right.
Yes.
There'd be other companies that would play in that sandbox. We're in the small residential application sandbox for now. So yeah, it'll be a ways away. But these we're kind of hoping these will be ready for your use early next year. That was the latest I heard today. Okay, if we should be ready for early next year. So it's kind of a neat package and very efficient at the home use. There's a lot of open manhole covers along the way. I mean, I remember reading some articles out of some newspapers in New York, on Long Island, where you are, Dave, where the homeowners did not tell the utility company that they were now making their heat with electricity, and they were billed at a much, much higher rate initially, and it was like cripplingly expensive because they didn't know, and they didn't know to charge them at the low rate, and they didn't really bother to say, okay, oh, whoops, sorry, we'll credit you. They said, sorry, hey, your fault, you're you know what, and that's no good. But there are definite advantages. Now, there's always that one thing that says, well, wait a minute. So I'm not burning fossil fuels at the house, but where do you think the electricity comes from, Charlie? Hey, that's not our problem, really. That's
Right.
coming from somewhere. They're creating the energy. Now, are they always going to be creating with energy with fossil fuels? We don't know. Probably not. They're looking for other ways to make it. Whether it's a wind farm, solar panels, solar farm, all that other kind of stuff. So they're going to be looking for other ways to make electricity as we go forward, but they're just starting this process now. So more good questions came in.
A lot.
Can heat pumps work well for hydronic floor heating and domestic water? Oh, Kerry, absolutely. That's kind of what they're designed for. Is
Kind of designed for that low temp, yes.
Yeah, any kind of low temperature application. So radiant floor heating, absolutely. But what about, radiators or baseboards that you think might need high water temperatures? Well, no, you can, if you've got the length, output for fin tube baseboard varies based on the water temperature you put into it. So, you can put, if there's a lot of baseboard, then yeah, sure. Cast iron radiators, same thing. There's a lot of different ways to do low water temperature heating than just floor heating. It's all a matter of design, right? Yep, low temp baseboard. Yep, you can do low temp baseboard. Mike Hansen brought that up. I'm not surprised.
And I did a session on that. I believe it was session 2 of the last classes that we had done, the factory class. I had done a low temp session. Oh, maybe that was winter. The winter essentials, I think I had done a low temperature class. So it was actually kind of like tying into the heat pump story, and trying to lower water temperature as low as you can in your hydronic systems. And now most of the days, we're way over tempered, I think, in a lot of stuff because we're way over radiated, other than radiant floors, obviously. So, and Kerry, does low temp create Legionnaire? No, because he's a closed loop. Right. We're looking at a closed loop system here. So you don't have to worry about that. It's when you have that open system and open to the air and mist that you can get and actually breathe in the vapor. So Legionnaire is actually is a respiratory issue. So it's not like drinking the water or anything like that. It's actually getting into the lungs that way. So
Gordon points out you'd have to heat 120 degree heat pump water to 180 to use existing heating radiation. Maybe yeah, maybe no. Again, it depends on the heat load and depends on how much. I mean, we've all seen those rooms in those houses where they lined every conceivable open bit of wall space with fin tube baseboard, or there's a big oversized cast iron radiator there. You do the heat load and find out what the heat load is, then you figure out, okay, this heat load in this room is, 4,000 BTUs. Okay, I got 30 feet of baseboard in this room. That's cray cray, as my daughter would say. All right.
Mhm.
Now you divide 40,000 BTUs by 30 feet, and you figure out how many BTUs per foot you need, which I can do right now. Let's check that thing out. All right, let's see. 4,000 divided by 30, that means I need 133 BTUs per foot. I bet you I can do that with 120-degree water. I'll bet you, depending upon the baseboard, I bet you I could get pretty doggone close.
And
So
most
again,
people are over.
and that's just an example. That's just an example.
I said, and here in my own house, I did the same thing. My house, before I renovated it to radiant floor, it was all fin tube baseboard, and it was way over radiated, right? And that's because Long Island has its own rule. And I know I got a few Long Islanders here, and you know that rule, right? What is that rule? Outside wall with a window, fill it. Don't think twice. You just fill it with radiation and you're done. And when I swapped the boiler in my house, I went back, did the heat load calc, took a look at the radiation, look at the worst case room, and said, okay, I need 155 degrees on a design day. On a design day, I could heat my house with 155. So, okay, now you're getting better in that heat pump range. All right, but that's on design day. So now when you start looking at outdoor reset and modulating the water temperature based on outside design, your heat pump's going to get you about $1.40. All right, so if I needed 155, all right, I'm short. But the way to overcome that with the heat pump is that, one, we're going to have storage tanks, and then two, on those really cold days, we put a couple electric elements into the tank to boost that water temperature up to what I need. You could, Gordon, yes, add more radiation to the house, but that's, now we're doing some surgery inside and some more dollars to the job. So exactly right. So if you want to try to retrofit in there, and it depends. I mean, if I needed the whole house to be 155 rather than that just one room, different story, right?
Right.
Then I might find other ways. If it's just that one room, I would just keep with the one electric element in there just to get that little bit of bump in there. And hey, we hit those design days less than 2% of the winter. So excellent.
Hey, George has got something for me. He says he's looking over my left shoulder and he's looking at components on my bookshelf behind me.
What are those things behind you, Rick?
Oh, there's
Those are
all
called
kinds of stuff.
books.
There's one thing I'd like to
There's
highlight.
books over there.
And,
Please
and,
highlight.
and no, left
Oh, the
shoulder.
other shoulder.
Now the other left, Dave.
Yeah. There's one thing that I would like to show you that's out of sight, but not out of mind. Oh, my word.
Okey smokes, Bullwinkle.
Oh, my. Oh,
He got a new
my
one.
Word.
Whoa.
What does that remind you of, guys? Look at that baby. Is
You're
that
gonna be pumping
sexy?
iron, man.
It's so sexy.
That's a
Yeah,
pump right there.
baby.
Yeah.
That's a brand. That's the first one I've seen in the flesh.
Oh. So folks, you realize that we're all about ECM technology, right? We talk about these little pumps and we do some cool things, but we're building those pumps up in the range of about 300 gallons a minute. This one's not, but I couldn't lift the one that's 300 gallons a minute, but actually they're half the weight they used to be.
Yeah.
But this is a little 1.5-inch pump. And anyway, we got some cool things to talk about down the road. We've actually already released them. We're doing training on them. We're teaching our reps, that sort of thing. But this is some cool technology. We're doing some wonderful things to make circulators in the ECM realm, light commercial, heavy residential, McMansion, starter castles, that sort of thing. We got pumps for those jobs in ECM technology that do some really cool stuff. So anyway, that's just a tickler to look forward to.
All the way up to 300 gallons a minute. That's the new VR series of circulators.
Look at that thing.
They're variable speed, 7 ways to Sunday. You can
Yeah.
set them full speed, adjust the speed. There's different proportional curves. There's different constant pressure curves. There's our own active adapt functionality for those areas in which we need it. It's backnet. It'll work with backnet and other types of building management. So it's pretty cool. And they're going to be available in cast iron for heating and stainless for domestic. And they come with that little insulation pack that you saw there to keep them nice and warm. And yeah, cool stuff. Very cool stuff. And that's the first one I've seen out in the wild. That's pretty cool.
Let's see.
Well, there's an awkward pause.
Are
Oh, yeah.
1.5 to 3 inch.
I was just
Yes.
going back to some of the questions that things went flying quickly before, so I wanted to make sure we didn't miss anybody's questions here.
Very good. Well, yeah, I mean, this is again, I want to go back to one of our very first topic. The first week was the new circulator efficiency ratings by the Hydraulic Institute, an
Yeah.
independent third-party testing and verification of circulator efficiency performance. And as of today, with today's technology, the highest efficiency rating the Hydraulic Institute is giving out is 188. All right, that is as efficient as you get. 5 circulators were rated at 188. TACO had 4 of them. Okay, Armstrong had the other. The next closest to 188 was 187, and that was TACO as well. The next closest competitor was around 181, 182, and most of their pumps were about 177 to 178. So that's remarkable. But that's just what we've been working towards for the past 10 years, and that commitment to making the very best circulators in the industry. Okay, nobody makes circulators the way we do, and this proves it. Nobody makes circulators anything remotely close to the way we do in terms of efficiency, in terms of options that you have. And the circulators we're talking about, the highest rated circulators, the VT2218, our Delta T pump, 188, and also rated by the Department of Energy as the most efficient and effective way to run a variable speed circulator is on temperature differential. That's a very important statement, but that's rated at 188. The 0015E3, our 3 setting super simple variable speed circulators, rated at 188. The 0018E, our multi-feature, multi-function Bluetooth circulator, is rated at 188. The VR1816, which is the exact same pump as the 0018E without Bluetooth, okay, just take the Bluetooth away, you get the same darn thing. That's rated at 188. Okay, so we got 4 of the 5 that are rated at 188, and the one at 187 is the 007E, rated at 187. So those are by and large, those are far and away the most efficient circulators. By and large, those are far and away the most efficient circulators there
I like that.
Yeah. So that's pretty cool. That's pretty cool.
Hey, look at Laura's question there. Laura, is that a cross-reference for what John's talking about, or just a cross-reference to show you what we have in ECM technology versus the others? You know, like if I have a model 0018E, what does brand X, Y, Z? So clarify that question, Laura, please.
Yeah. If it's HI ratings, yes, stay tuned. We are working on that. But if it's other cross references, yeah,
I'm working on that too. Actually,
I'm
working on that personally myself. Yes.
Okay. Well, you guys talk. Hold on one second. I'll be right back.
Yeah.
Alrighty.
But right now, Dave, there's a website, right? It's an HI website that we can send them to. They can look at all these numbers themselves. I don't have it memorized
That's correct.
yet.
Yeah, it wouldn't be a cross reference there, but yeah, it's er.pumps.org that you can take a look at the HI labels. Now they don't do a cross reference and compare one to the other. You'd have to look at each one and make sure you choose the right one there. But as far as, you know, just doing a cross reference between us and theirs, well, one, yes, John shows as we have it on the box, and I also plan on putting together a sheet sometime soon, and maybe some other fun goodies along with that too. So we've got some stuff to work on. We do have one, unfortunately, up on our website, and I say unfortunately because it hasn't been updated in a while. It's a PDF download for some spreadsheets, so you can see that there. So thank you, John. Or you're just trying to get it to focus?
I'm trying to get it focused, but that's on the box of the 0015 E3 and really all of our 00 E series circulators. There's a cross reference just of what each circulator, what Takeo, Grundfos, Armstrong, Xylem, and Velo circulators the 0015 cross references to. So that,
Yeah.
and that's on the 007 E box, the 0018 E box. That's on all of them. So there's a handy cross reference there in terms of the Hydraulic Institute cross-reference. We are working on that too. So good.
So
good.
Sean
That's
just
exactly
came
what
in
you were
with a
looking
couple
for.
of questions, and thanks, Sean. So he's talking about, in a cold climate, wouldn't you have to size your boiler to accommodate both the heating load and the expected domestic hot water load? Not necessarily. And nowadays, your domestic load is usually larger than your heating demand, believe it or not. And a lot of people don't think so, but when you really, dive down into the numbers, your domestic load is going to be larger. Size the boiler to that, and then we put it on priority, which means when the domestic calls, you don't want to, unless you really need both to be on at the exact same time. Usually when you shut down, you go on priority, which means you shut off your your heating demand for a short period of time, which means maybe a dozen minutes or so maximum, and then it puts the heating back on again. So more than enough. You don't want to have to add both of them together and way oversize the boiler, because then you're going to short cycle like man, and you're just going to kill that thing and waste more energy than you really needed to.
Right. And the thing about our SR and ZVC controls have built-in, they have built-in domestic hot water priority, which, as Dave said, when you're recharging the DHW tank, is that we turn off the heating, but the controls themselves are equipped with something called priority protection. Meaning, say something were to go weird with the aquastat or something like that, and it says never get satisfied, and you could conceivably keep making domestic hot water forever and ever and ever. Well, the control's a little smarter than that. Basically,
Yeah.
when the domestic hot water starts and we go into priority, the control says, all right, cowboy, you got 1 hour, go. If you're not done in an hour, we're going back to making heat. All right, to keep the house from freezing up is kind of where we're at there, and maintain indoor comfort. There we go. So yeah, you don't have to worry about that. And the other question you had was about if you were to put a tempering valve and boost the tank temperature. Well, doesn't that use more energy? Yeah, a little.
Yep.
Little. If you need the capacity, you need the capacity, right?
It's a
Would it be
simple
better
way to get it done. Absolutely. Yeah.
If you need to improve the performance, you need to improve the performance. And
Right.
understand what's the standby loss, Rick? You work for a company that sold these. What's the standby loss on one of those tanks anyway?
Half a degree an hour.
Yeah. There's
So,
not a lot.
and
Yeah,
again,
there's a bigger.
yeah, depending on what the aquastat setting is, that might be, 5 hours before it ever calls again. So there's a lot of variables there, but yeah, these tanks are well insulated. The fellow that had the Viessmann question was talking about that, and Viessmann does a great job, just like others, of insulating their tank. That tank will sit there for a really long time and not lose enough heat to ever bring another call from that aquastat. So anyway, Indirect, I'm sold. I love them. I've lived with them for years and years and years, and they just work really, really well and do a really good job based on what John was talking about tonight. If you size them right, you do this stuff right, you'll get the most recovery you'll ever get from any other type of device that's other than direct fired. And with direct fired equipment, you got metal fatigue, you got, we could go down the line talking about why an indirect might be better long-term than a direct fired piece of equipment. We've seen that time and time again. So anyway.
So the solutions that we showed today with adding a mixing valve to your indirect tank is the option first, right? You've got a customer that is not getting the hot water they want or demand, right? So that would be option one. Option two would be to, yes, put in a bigger tank. Option three is to throw in a bigger boiler, because I think we went through that math also, John, right?
Yep.
If you had too small of a boiler in the application. So, and then option four is doing it all, All right, new boiler, new tank, and a mixing valve. All right, if they don't have enough hot water, then I don't know what else you could do.
Yeah.
You know, um, so adding a mix valve can help you get there. It may not be the absolute answer, but it's probably the least expensive option you've got to increase their capacity in their house. So, and then of course, if depending on where you are in the country, if it's code, all right, make sure you got the temperature set properly also. All right, make sure that you've got that 27-degree spread if that's the valve that you have in there, so that it operates better and gives them the longer operation, the longer duration of water there. So
Yeah, Sean asked, are indirect tanks better insulated than conventional direct fire water heaters? Absolutely, yes. Those have regular fiberglass insulation wrapped around them, and they have that big old hole in the middle, right? These things are fully encapsulated with 2 inches of rigid polystyro, what the heck ever it is, super high density. BTUs aren't getting past me foam. Okay, that's what they're insulated with. BTUs go looking at the tank, go, screw it, we're going to stay here.
Hey,
There's
John,
nothing out there we need to see.
one thing to point out, a few years back, and I don't remember, it's probably been 5 or 6, all the water heaters had to come up. Remember when we started talking about why we want to increase the temperature of the water in the tank? That's because
Mhm.
of the insulation on replacement. You might have to put a 40 in the place of a 50 because now the outside dimension is getting
Right.
bigger. Well, that's what's brought on by the new insulation requirements. So I don't know. I can't say personally, how much better insulated they are. The one thing I can say is the manufacturer will show you what the thickness and or R value of their water heaters are nowadays versus what, like John was talking about. They used to just have a little blanket of fiberglass around them.
Right.
So yeah, just talk to the manufacturer and look at their information and see what their new requirements are for insulation.
And they used to sell water heater blankets. Remember those? You could buy
Yes.
those. It's
Yeah.
an extra foam, extra
Extra.
insulation you could wrap the tank with. And somebody always wound up putting them on a gas water heater right up against the draft hood, and bad stuff would follow. Yeah. So yeah, there's that goes all the way back, man. Very good, very good. You can get your house insulated well, including getting really good one. Yeah, I mean, there's so
Yeah.
many ways to button up an envelope nowadays as well. It's really, really interesting. I can remember an old friend of mine that I grew up with in high school. She became an architect, and she was interesting. She would not encourage her clients to go overboard on windows. Basically, the houses she designed weren't stupid. They didn't have that whole south-facing wall of glass either. She was reasonable about it, but she was able to show that if they went from a standard, double pane, low E wood or vinyl frame window up to a super duper window, the returns, she was able to show to her clients that the returns were diminishing. That it wasn't necessarily worth it. They might be better served with, if they wanted to do more insulation, do more in the walls, that kind of thing. Um, uh, it was an interesting take. I'd never heard it before, but here was an architect basically saying, don't spend as much money on windows. You can spend it elsewhere, but don't get cheap windows. She wasn't saying get cheap, crappy windows. Get good quality windows. Our value was a 3.77. U value was 0.36. Good industry standard, well-made, well-insulated windows, they're going to do a good enough job. Yeah. Yeah, Richard McGrath says the
Yeah.
best windows,
You see that?
best windows are still shitty walls. There you go. Oh, I'm gonna quote you, Richard. Okay, I
That's
am gonna
right.
quote you. Yeah, but window salesman will tell you they can give you 100% better window, but R1 to R2 isn't great. That's right. That's right. It was a diminishing return. I thought it was pretty interesting. I'd never heard anybody put it quite that way, but she really explained it pretty well. And she wanted to use our software that we had at the time, the Flow Pro Designer, to show that. How does it change? How does it change the load? Not very much. Anyway, cool. All right, any more questions out there, guys? Anything else you guys want to talk about? Dave, anything you want to talk about? Rick, anything you want to talk about?
I'm just
Guys
gonna
and
finish.
gals.
We
We got gals on here too,
Yep,
man.
guys and gals. I'm sorry.
Guys and gals.
I do that generically.
Just
I
say
call my
folks.
daughters guys.
Folks covers everybody, man.
Folks covers
Folks.
everybody. Yes. Yes. We've all been through HR training. There you
I
go.
was just going to point out that Sean was also asking before about the, when we were fighting back and forth with the, the temperatures and the ratings on the boiler between, size of the boiler, whether it's for the heating load and the domestic load, or do you combine it? He was asking about also mod con. So
Mhm.
mod con, same thing. Same difference there. The only thing that might be coming in different now is when you're looking at combi boilers where you have a separate heat exchanger built in now. If you're using an indirect tank, then it's just same boiler size as to match what you're looking for there. Now your combis, a little bit different. So now you need to take a look at both heat exchangers or both outputs of the heat exchanger to match what you're looking for there. So excellent, Sean. Thank you.
And even though, if you use a mod con and you size it for the domestic load and you figure, well, it's going to modulate down and it won't be oversized on the heating load because it's just going to modulate down. So, well, yes and no. Yeah, you won't be oversized on the high end, but now that 10-to-1 turn down ratio might just be a 4-to-1 turn down ratio or a 5-to-1 turn down ratio. We don't know. It won't be oversized on the high end, but as it gets warmer out and that turn down ratio goes down more and more, it still might very well be oversized for most of the heating season. And when you're down on your lower firing rates. So that's the other part of the equation you want to look at. So yeah, I won't be oversized when it's wicked cold out, but how often is it wicked cold out? It's only wicked cold out about 2% of the heating season. The bulk of the heating season, you're at 50% of the heating season is at 1/3 load or less. So you got to weigh the two, right? What did my cousin Benny say?
I want to talk about Matthew's question here. It's talking about air exchanges at a 50 pascals negative. I believe, Matthew, that's what you're talking about. And actually, that is surprising because it used to be 1.5 at 50 pascals, which was back in the day, and I'm talking 25, 30 years ago, was really good. You're telling us that it's down to 0.5 air exchanges an hour at a 50 pascals blower door. And I'm assuming that's what
that's
you're
coming. It looks like it's that the way I'm reading it from is that it's coming. Oh,
Yeah.
okay, yeah.
Oh,
Yep.
mid 2030s. Okay, all right. I'm gonna say, wow, that's tight, baby. Again, 1.5 is tight. That came from Hot 2000, which was Canada, and Alaska adopted that Hot 2000. They called it Alaska Craftsman Home Program. And that's what we were doing up there, just kind of copying what the good Canadian brethren, the frozen chosen brethren, were doing up there. So anyway, good stuff, Matthew. Yeah, it's going to be it'll be interesting.
Travis had asked about the ECM circulator ratings. Is 188 the cap, or is that the highest they've tested? It's kind of the highest today's technology can go. There's really, theoretically, there's no cap on that rating. There's no limit. It's just the highest that today's technology can go. Would new technology 10, 20, 30 years down the road be able to go up even higher? Probably.
Yeah.
That's just the way it is. How much can the envelope be pushed?
So basically, if I remember correctly, when it comes to the ER ratings on these circulators, the best of the best of the best that you can't get any better, it's perfect and alignment to the planets and everything like that, I think was a 204, if I remember. Based on the math that they have come up with, it's around a 204. It wasn't a number that was just pulled out of the air and dropped into place. It was based upon technology, and that 204 will not stay as the highest number. That number can actually change as years go on and technology changes, and as we get more and more efficient with the operation of our circulators. So right now, with that 204 being the high end, the highest that you could ever possibly get to, but it was also known it's an unrealistic number to reach today. Then they applied the calculations, and the VT 2218 came in at the 188 number. Right.
Right.
Yeah.
Once we get that cold fusion circulator technology down. We're going to be busting past 204, man. It's just that we're leaving that in the rearview window. I'm waiting.
I
Yep.
love it. I love it.
Well, the nuclear one's coming first before the
That's
coal.
right.
So
All we need
it
to
just
do
takes
is
a little
agitate
speck
water.
of the
Yeah.
uranium to drop in there. We'll put a hatch on there, drop it in, close it up, and you're done.
But
So
you'll be getting a hazmat suit. If you don't get the hazmat suit, you will be glowing with Takeo After Dark. I mean,
nah,
That's right.
it's small. It's a small amount. I wouldn't worry about it for a circulator. Yeah.
is that why the doctor hides behind the lead door when they take X-rays? Yeah, I'm with you. Sure, Mr. Fusion, right? Great
Pulse
Scott, 1.21
technology.
gigawatts. Oh my goodness. Oh boy, hey, this was a lot of fun. Are we still going on here? This was great. As a group, you guys were you folks. Thank you.
Guys.
Sorry.
Yeah.
You folks were awesome tonight. We've enjoyed this so far, and we're not going anywhere really. I just wanted to let you know that, but we will hang out as long as you have questions. You
Maybe
keep
for
asking
another
questions.
cocktail.
Well, what do you have in there? Is that a
Well,
Mayotini?
it was a Mayorita,
Mayorita, a Mayorita.
but it's all gone now.
Hmm.
There's
Well,
only about an hour and a half limit to one of these, so you know.
God, I've
I
been
had
way
a
too busy tonight. Way too
first
busy.
I had a slow main fizz.
Good thing I keep the bar with me right behind me.
There it is. Poland Springs sparkling water. So this is a lime slow main fizz.
Yeah,
Poland Springs
that
is in.
reminds me of a slow gin fizz. That's what you were
Right.
talking about. Yeah.
That's right. But this is a low main fizz, sparkling lime flavored sparkling water from Poland Springs.
Yeah.
Sorry about the hair loss math.
Ah,
Richard, you're killing me, man. You're killing me.
oh,
Oh no, you didn't see the comment. He did have a comment in there about talking
I
about
saw the comment.
Oh,
I
you
saw
just-
the comment. I saw it. I was hoping it would just go away, but no, he brought it back. Thank you, Rich. Thank you, Rich. All right. That's okay. I'm going to hang on to this as long as I can. As well as this. All the rest of it.
the fur.
The fur, yes. Just think of an aging Chewbacca and you've got it.
I know.
All right. Just don't do a comb over. No, I don't have
No.
enough to do a comb over. You can't comb over with that, man. There's
You
not
look
enough.
like Donald Trump. Oh,
Oh, no. All right. No comb over for me, Matthew. No,
yeah.
I whenever I get a haircut, I said, I just want it to look like I don't have a comb over, and I know I don't have much left, but just do what you can with it. I still get charged the full amount, even though I don't have that much hair left. But that's all right.
Don't do a como either. Oh, yes, Douglas.
A quom over. That would be a quom over.
Como.
Yeah. I get a nice hair helmet. That's what I wanted to add. Go get a wig. Oh, all righty. Well, look, that sounds like the questions are slowing down and we have devolved into political hair jokes.
Yes.
So time to stop.
Yeah.
All right, folks. Hey,
Satire.
thank you all once again for joining us on this Wednesday night. This was an absolute blast. We thoroughly enjoyed having you with us, and I hope you guys got a lot. I hope you folks got a lot out of this presentation. It was really, really fun to do, and I hope you'll be able to use this info starting tomorrow in somebody's basement. So
That's right.
very good. Take care, everybody. Have yourselves a marvelous week, and we will see you. Hey, second chance at love, man. Next Tuesday night, we're going to be doing the same presentation again, 9 p.m. Eastern, 6 p.m. Pacific. Next Tuesday night.
All you people on the left coast and closer, tell all your friends Tuesday night.
There you
come
go.
on down.
Same presentation, just a little bit later at night, and then next Wednesday night, Mr. Mayo has the con, and I think it's you, yeah. And boy, oh boy, now you'll see some real stuff. I'll tell you what. All righty, folks. Appreciate
Excellent.
it. Have a wonderful night. We'll see you next time.
Enjoy, y'all.
Good night. Sleep tight.